For second question, we have marks in an English test is normally distributed with a mean of mu and variance sigma square. Okay, so mean and variance is not given in this question, but they gives us two clues. So the first clue is 10% of them score more than 75 marks and 25% of them score less than 40 marks. So we need to find mu and sigma. Okay, so this one is like the other way around question. Previously we are given mu and sigma, we need to find probability, but now it's the other way around. We need to find mu and sigma. So before we solve this question, let's set our x, our point of view first. So since marks in the English test is normally distributed, so our x would be marks of the English test. So even though we are not trying to find the probability, we are finding the mu and sigma, it's okay to use the 5S method, because these two statements we will need to use the normal distribution graph to help us find, right? So it's okay to use the 5S method. So for the first S, we need to write out our statement from this sentence. So the first statement would be probability where the pupil score more than 75 marks, or which we can write it as Px more than 75, the probability is 10% or 0.1. The second statement would be the probability where pupils score less than 40 marks, or which we can write it as Px less than 40, the probability is 25% or 0.25. Right? The second S is search, so we don't have anything to search because this is the thing we need to find, so we can skip second step. The third S is standardize, so for each of the marks here, x75, x and 40, we need to use the formula. Okay, so minus mu divided by sigma. So here we don't have the values, so we will just put mu and sigma for each. Okay, and here this part and this part we can transform it to become z. And our fourth S is to sketch. So using this statement, we need to draw it into the normal distribution graph, right? So now we are trying to sketch the area that we want, right? So here, if you notice, the sign here is greater than, so this means we need to draw it to the right side, but we only sketch 0.1 of the graph, or meaning 10% of the graph. So you can imagine that our area would be something like this. Okay? Because 0.1 is quite small and we draw it to the right side, so you can start almost near to the end of the graph. Then I will put my z value here lah, the starting point. Then for our fifth S is to select the z value from the table, but we need to satisfy the two conditions first, which is the area must be from one side only and must be from the right, which if we look at the graph here, we actually satisfy both criteria. Okay, so this graph is ready and we can go to the tables to find the z value. Okay, but before that, let's sketch the graph for the second statement first. Okay, so for this one it is less than, so we should draw it to the left side, but we can only sketch 25% of the graph. Okay, so from this graph, since we are at the left side, so we need to draw it somewhere starting here. Okay, and then to the left side, and let's put the z value here. Okay, if we go to the fifth S, the two conditions here, we only satisfy one of it, which is one side. This one we fail because the area sketches from the left side. Okay, so what we need to do is, because this graph is symmetric, meaning if I split this graph by half, left and right same shape. If same shape means same area, so I can move this area to the other side. Again, because it is symmetric, but the only thing I need to change is this value. I need to change it from negative to positive. Okay, this value is already negative, so if I add negative to it, it will be negative, negative, positive. Alright, if you're wondering why I put negative here, because the original value is already negative. Alright, so now you can see that this area satisfies both conditions, one side and from the right. Okay, so now we are ready. Oh, sorry, before that, we need to write a statement for this graph first. Okay, so we can write it as the probability where z is more than, because here our area sketches to the right, so we need to put greater than here, and this will be our new z value, so I'll put it here. Then our probability didn't change because it's symmetric, same area, same probability. Alright, okay, so now we can go to the tables to find the z values for both cases. So for the first case, our probability is 0.1, so to find the value of z, the first step is to find the first value which is larger than this number. So if you look at the numbers here, the first value would be this one. Okay, so we'll write the probability here. Then the second step is to find the differences or minus. So if I minus, the value would be 3. And by looking at the same row, let's look at whether there is 3 or not. Okay, there's no 3, so let's look at the values which is near to 3. Okay, so it can be either 2 or 4 for this case. Okay, because the differences between 2 and 3 and 4 and 3 is the same. Okay, so both is accepted. So for us, let's choose 2 lah. Okay, so if we find the differences between these two, almost we can get 0.1, which is fine. Okay, so now let's find the 4 digits. Okay, so from section A it will be 1.2, section B will be A, section C will be 3, so our value will be 1.281. And the probability for the second case is 0.25, so the first step, find the first value which is larger than this number, so it would be somewhere here. Okay, so let's put the probability here, then we find the differences between these two, which is 14. So from the same row, find 14. Okay, we don't have, so let's find the number which is closest to 14, okay, which is 30. Okay, so by minusing these two values together, almost we can get 0.25. Right, so let's find the 4 digits from section A, B and C. So section A 0.6, section B 7, section C 4. So our z value will be 0.674. So coming back here, we can write that according to the tables and then the result that we have gotten. Okay, it's the same thing as the statement here, it's just that I replace this part to the z value that we have gotten in the tables. Okay, so now with these two statements, I can compare the z values. Okay, this and this. So now let's form an equation where mu is the subject, which is mu on the left side first. Okay, same goes to the second case as well, according to tables and then the result that I've gotten in the tables, and then I compare this value and this value. Okay, and again mu on the left side. So why I put mu on the left side is because it's easier for us to calculate the sigma. Okay, so you can compare the mu from both equations and then find the value of sigma. Okay, so here is just normal calculation, and the sigma you'll get is 17.902. So once you get the sigma, you can sub to either one of the equations to find mu. Okay, so for me, I would use this one. Okay, and then the mu that I will get is 52.07.